that we are going to do to learn these content objectives right here. Right? Constructing viable arguments and critiquing the reasoning of others. It's making, creating ideas, coming up with them, and thinking of evidence for those ideas. And when we critique the reason of others, then we're listening to their ideas and pushing on them to help each other become better. Looking for, making use of structure, looking for and expressing regularity in repeated reasoning, all to do these three things. Dewan, can you read our first objective?
I can't. Oh, wrong one. Identify linear, quadratic, and exponential function.
We should be good at this by now. What do we know about a linear function? It creates a line, yes.
Additive rate of change.
Not just an additive rate of change, a constant additive rate of change, meaning we're adding the same thing each time. Because a quadratic has an additive rate of change as well, it's just not constant, it is linear, right? That quadratic has that linear rate of change, whereas an exponential has a multiplicative rate of change. Do not forget that. And we're going to practice, right? Look for and express regularity in repeated reasoning with writing recursive and explicit equations for the above functions, and then determine those rates of change in linear relationships. By the way, what do we call the rate of change for a linear relationship? It is the first differences, but it's called something very special.
It starts with an M.
Well, the letter we use to indicate it is an M. The word starts with an S.
Slope. Yeah.
Slope, right? Talking about slope there. All right, we finished 8b yesterday, correct?
Yeah.
Yeah? I know we did 8a and c. Did we finish b? Yes. Okay, so what type of function are we looking at here? Because one, we need to do a recap. Hey, Dewan, I'm going over it right now. We're doing a recap for those of us to bring back some important ideas. But two, we need Dewan to catch up. So what type of function were we looking at in B?
Quadratic.
Why did we know it was a quadratic? And don't forget, it's not just quadratic, it's a quadratic function. Right?
Increasing and decreasing.
Do you see it increasing and decreasing?
Yeah.
Because I just see it increasing.
Decreasing.
I don't see it decreasing.
Decreasing and increasing.
I don't see it doing both of those.
Just increasing.
It is just increasing. And I will say that somewhere it increased and decreased, but we don't see that right now. How did we know that this was a quadratic function? By the way, fxn, anytime I do that, function. How did I know it was a quadratic function?
Because it didn't have a constant rate of change.
It did not have a constant rate of change, it had a linear rate of change, right? So we looked at our first set of differences. Like, man, that's not the same thing every time. But we looked at the second set of differences, and that's constant additive. And so if the second set of differences is constant additive, this is linear, right? A linear function has a constant additive rate of change. So it was constant, so it was a linear rate of change. Right? So yes, I will agree, Dewan, at some point there was both increase and decrease. We don't see that in this table. We do see a linear rate of change, so we knew it had to be quadratic. Okay? Now, what was the explicit equation?
X squared.
Now, I want to point this out because this is important to hold on to because this will be informative later. If you have a quadratic function, what will you always have in the equation?
Exponent.
Not just an exponent. Because remember, sometimes you could have something like, 2 to the x.
The second power.
The second power, right? X squared is a part of that quadratic, right? The second power is there. Now, so if I know it's a quadratic, I know there's got to be an x squared somewhere. In this case, 6 squared, is that 36? 8 squared, is that 64? 9 squared, is that 81? Right, so I didn't have to do anything else, that's the equation. But sometimes you may have to add or subtract something. But if it's quadratic, it is x squared. Now the recursive equation, this is important to pay attention to. First off, how does a recursive equation always start? And then what comes after that f of n minus 1? The rate of change. So what we did, or what I recommend doing, is create a table just for your rate of change, because that's going to help you figure out what to put down there. Alright, so x and y, and remember I'm going to indicate that this is my rate of change. This is my linear rate of change. So what are the points that are going to go in this table for the linear rate of change? I mean, I see the first part of the rate of change is plus what? So what's the x value for that? 7. Remember, it is the 13 is leading to the 7th term, so it is 7 13. So then it is 8, 9, 10. Because now we can more clearly see, hey, that is in fact linear, so I need to write the equation of a line. What equation is most appropriate for the points in this table? Point slope. I don't have a y-intercept on it. This isn't good for standard, but I do have point slope. What point did we use yesterday? What point did we use? Look at the recursive we wrote. Did we not finish it?
13. Wait, that was we would put for the what's it called? Rate of change. Yeah, that was good.
I mean, we picked a point, and that's the first point up there, right? So we can do point slope with it. Now, I do want to remind you, don't ever forget, slope is equal to rise divided by.
Right.
So most people are just like, hey, that's plus 2, that's my slope. But really, the y, that's my rise, isn't it? So that plus 2, is that my entire slope? Notice we can actually find slope from a table, but we need to recognize the y, that change in y is my rise plus 2, and what's the change in my x, my run? That's why the slope is 2, right? My rise and my run. So, what's going to take the place of m? 2 times
X minus 7.
Plus 13.
So that is what goes right here. Plus 2 times x minus 7. Then you need some starting point. Notice, very specifically, that's the equation of a what? Line, because what type of rate of change does a quadratic have?
Linear.
Linear. We all get with those ideas. Alright. So here is number 9. It is on the back side. Group number 3, I want you to do D. Group number 2, I want you to do E.
Huh?
Group number 1, I want you to do F.
So you just copy out.
So, each of you need to determine the type and characteristics of each of these functions, the explicit and then the recursive. So let's work together.
We got two.
Sorry, this is group 2. I said that, I just didn't put it. Group 2 is E. So let's get to work.
You did us wrong.
What?
You got no fractions.
Aw, you poor baby. I wonder if you'll be okay.
You will, because they got the answer. These numbers look different. Oh, yeah. I'm sure.
Oh, by the way, at the end of class, you will have one of you will write the answers up here, and then someone else will explain it to the class. So you need to be able to know why those are the correct answers.
No.
So we're just going to go with whatever Zay's is, or are we going to work on it?
We're gonna look at it, and then we're gonna see if it's right. Yeah.
You better make sure you make sense out of it and can explain it.
We're gonna see why it's right. Let's see. Let me see.
Let's see you work.
Yeah.
You'll have to work a little bit to start talking with each other.
All right, so